Hey, welcome back to another video. My name is Bharat, and in this tutorial I'm going to be showing you how you can build a pump.fun clone using React, Moralis and Solidity. So let's get started. So like you can see from my screen, this is what we're going to be building in this tutorial. And if you're not aware of what exactly is pump.fun, so pump.fun is essentially a platform that lets you create meme coins on top of Solana. And it's been going very popular. It has gotten a lot of revenue. As you can see here in the news, it has surpassed over $100 million in total revenue. And we're going to understand how exactly pump.fun works, what's really special about it, and how you could build the same for any EVM compatible blockchain like Ethereum using Solidity. So that's what we're going to cover in this tutorial. And before we get started, let me just give you a quick overview. So this is what we're going to be covering: how pump.fun works, how does it kind of help you prevent scams, what's a bonding curve and why that's an important part of our implementation of pump.fun, and building the smart contract for it and the front end, and what APIs of Moralis you can integrate in order to build this. So that's the agenda. So to understand pump.fun, there isn't any better way than actually just going to pump.fun's website. And like you can see over here, you see a lot of things happening in the screen and it's kind of overwhelming at the beginning. But if you look at it, each of these are basically meme tokens which are created by multiple people. And to create a meme coin, you can just go into start a new coin, give your coin a name, ticker, description, and if it's like Twitter, Telegram, the website, etc. as well for the particular token. Once you have done that, you can basically pay the fee. So to build to deploy your meme coin through pump.fun, it's going to cost you zero point 0.5 Sol. And coming to the mechanics of this, what actually happens is Pump.Fun smart contract basically controls your particular ERC20 meme coin or any token standard which you're putting, and it basically has full control over it, which means that if you're someone who is trying to create like a scam token or something, you can't have any preset supply or team allocation, etc. So all the tokens that are created through Pump.Fun are kind of safe in that way that there isn't any big team allocation or any mysterious token holders, because all of that is visible on chain. And coming to how exactly it works, you pick a coin and it works on the concept of bonding curve. So bonding curve basically means that the price of the token is not constant. It's basically goes on a bonding curve, and the bonding curve that Pump.Fun uses is an exponential bonding curve, which means that the early investors of a token get a benefit because they can buy in a large amount of tokens for cheap, and the people who come in later at a higher basically come in at a higher price. So that's how the bonding curve logic works. And 20% of the token supply is put into is $12,000 of liquidity, which is once the token basically reaches a market cap of 69K. You can see here that $12K of liquidity is basically kept and in radium, and it's burnt. So generally the way it works is when the token is basically created, the max supply is set. In pump.fun, these meme coins have like a max supply of like around 1 billion tokens, and 20% of that max supply, which is around 200 million, is reserved for creating the liquidity pool on Radium, which is basically the DEX of of Pamda of Solana. So like you can basically see, the it is up to the person who created the meme coin to market that remaining 80% of tokens and basically sell it off. So the moment they manage to sell the 80% of the token, the bonding curve basically completes. And the moment the bonding curve completes or reaches the $69K worth of value, then the tokens are deposited onto Radium, and the LP token is basically burnt. So that's how the uh, Pump.Fun works. And like you can basically see here, these are some trades which show you for this particular token, people buying and selling, and what's the holder distribution for this particular token look like. You also get to see all of that. So going back to the page, you basically have this platform that lets you create these meme coins. So we're going to build something similar, and we're going to do it on top of EVM chains. So which means that our token that we are creating is essentially an ERC20 token, but we are going to have the mechanics of pump.fun, which means that each token that's created through our version of pump.fun is going to have like a maximum supply. 20% of that token is again going to be reserved in case the funding goal is met. If let's say the funding goal, in our project we are setting the funding goal as 24 ethers. So the moment any project, right, any meme coin here raises more than 24 ether, then the uh, funding, basically the bonding curve basically tells you there aren't any more tokens to purchase, and the 20% which was initially minted gets put into Uniswap along with the ether which is accumulated, which is 24 ether. So these both get put into a liquidity pool in Uniswap where people can then trade. So this is essentially the token pages for each meme coin. If you go in, it shows you some details about the meme coin, the bonding curve progress. So as more and more people buy, the bonding curve basically keeps filling up, and you can see here the remaining tokens available for sale. So there's still 800,000 tokens. So for our example, we are going to use the maximum supply as 1 million tokens, and 20% of that 200,000 tokens is reserved once the bonding curve is met. The moment the bonding curve is reached, all the liquidity from the bonding curve, that is 24 ETH and the 200,000 tokens, is used to create a liquidity pool on Uniswap where people can then trade. So that's essentially how our platform works. So what we can do now is we can get started with the smart contracts. So to do that, just open up your terminal, create an empty repository. And once you have done that, let's do npm init. So we've done that. Next step is to basically install Hardhat. So for that, we're going to do npx hardhat init. And we're going to choose create a JavaScript project. Select the project directory, go ahead and install the sample project dependencies. So if you look at and try to understand what exactly our smart contract needs to do, right? It needs to be able to create a meme coin. So if you can see here, we are also charging a meme coin creation fee. That's essentially how the platform earns revenue as well. One of the ways. So here, the meme coin creation fee, we're going to set it to 0.001 ETH, which means anybody coming here to create a meme coin is going to pay this much as a fee. And all the tokens that are created through our version of pump.fun is going to have a max supply of 1 million tokens and the initial mint of 200 tokens, which is going to be kept in case the funding target is reached. Once the funding target is reached, then both of these are used to create the liquidity pool on Uniswap. So that's on the meme coin creation. And if you go into a particular token, you can see how much is the bonding curve progress, and you have a way to buy these tokens as well. So if you're planning to buy, let's say 100 tokens, or let's put 1,000, you can basically see how much it's going to cost you. It's going to cost you 0.03, and we're going to see how exactly this pricing also works in our smart contract logic. So let's just open that back and see. You can see that, yeah, it was created. So now I'm going to open this on VS Code. Okay, I guess there's some issue. Let's just open it up like this. Open, uh, and yep, we have basically got in our folder up and set up. So you can see this is the standard setup of a Hardhat repository. So it looks like you have a contracts folder. That's where your contracts go. Ignition, in the latest version of Hardhat, it's called Ignition, and this is where you have your scripts for deploying the contracts, etc. Then you basically have the node modules, the test where you write the test cases, etc. So to go ahead, to start with, let's create our contract on contracts folder, and let's call it the token factory.sol. Is okay. Let's do the standard stuff. SPDX license identifier, MIT. and put in the version of Solidity that we're planning to use. So I'm just gonna copy this. Okay, and now you can create the contract token factory. So within token factory, right, let's just try to understand what all functions we need. The first function you basically need for sure is to create a meme coin. So let's call this particular function as create meme token. So, and to create this meme token, you're going to take the name of the token, the symbol, the description, and we're also going to take the image URL. Aside from this, that's it. This is all you require. Now let's make this function public. Let me just toggle word wrap on. Yep. So we're going to make this function public, and it's going to return the address of the meme coin that we just created. So, okay, we have to put memory here. Done. Okay. So now to do this, we're going to use the ERC20 standard, right? So which means that we need to have a token.sol. So let's create a token.sol. And if you're aware of common token standards, there are a lot of token standards. For our tutorial, we're going to go with a token standard called ERC20. And for ERC20, we're going to go into the Open Zeppelin docs. Uh, and we just have to install the npm package for Open Zeppelin. So once you open this, you can go into overview. Yep, this is what we need. So once we got this, you just head back into our smart contract folder. Let's open this up and open the terminal, and let's just install this. Okay, so you can see that it was installed. Now what we can do is basically we can again have the standard stuff, and let's import our ERC20 token package. So to import, you're going to just do import at Open Zeppelin slash contracts. You can basically find that out here. So you have Open Zeppelin that we just installed over here, and you have to go into contracts. Within contracts, we'll be going into tokens. So let's just contracts, tokens, token, and then you have ERC20.sol. So if you go into this, this is the contract that we need to inherit from. So to create our ERC20 token. So now once you have done that, let's just create our token. And now you have to inherit from the ERC20. Let's try to see what the imported file not found. Open Zeppelin, contracts, token ERC20. Okay, we missed a folder over here. See, ERC20. So let's just put that again, and we're good to go. So now that you have done this, next step is basically to create the constructor. So the moment this particular smart contract is deployed, the constructor will basically be called, and within the constructor, we're gonna have the name, symbol, uh, which are the arguments for ERC20. So you can again verify that by going here. And if you look at the ERC20 constructor arguments, You can see the name and symbol is basically present, so that's all you require. So now we have name and symbol, but let's also have the initial mint value as well for this particular function. And what it's going to do now is within the constructor, uh, we're going to call ERC20 of name comma symbol. Okay, we also have to put memory here. Done. Now you're basically creating the ERC20, you're calling the ERC20 constructor to set the name and symbol of that particular token. And the next step is to actually mint a given number of tokens. So how many tokens do we want to mint? That's basically the initial mint value. And we're just going to mint it to msg.sender. So initial mint value. So this is what's here. And what exactly are we doing here is that when the meme coin is created, around 20% of the total supply. So let's also define some constant. So the max supply of our tokens is going to be 1 million tokens. So we have basically defined the max supply as 1 million tokens, and decimals is basically the smaller notation of our ERC20 tokens. So how divisible is our token? And a standard convention for decimals is to basically go with 10 power 18, which is 18 decimals. So this is which is going to set the decimals as 10 power 18. And the next step is the initial supply. Like I mentioned earlier, the initial supply is going to be 20% of the max supply. So we're going to do 20 star uh, decimals, 20 star max supply. So the max supply is actually going to be this number times the decimal. So you just have to multiply the decimal again after this. So let's do this. And 1 second. Yep. So essentially what we're going to do is the initial supply is going to actually be 20% of the max supply. So the max supply is set as the number of tokens, which is denoting the maximum supply of our particular thing. And that's actually 1 million times the decimal value. So that's that. Now, initial supply is 20%. So 20% into max supply divided by 100 gives you the initial supply. And now what we're going to do is we're going to import the other contract that we just saw. So let's put in the import that we just created dot slash token dot sol. And what we have to do is we have to deploy this particular token contract, right? So to do that, you can just token, create that within here. So this is essentially why we're calling our contract as a token factory, because it basically is able to create as many ERC20 token contracts. So now that you've initialized this, now you got to use the new keyword and you're going to put the token. And over here, you basically put in the arguments for the constructor. So that's the name. Then you have the symbol and you have the initial mint value, which is basically init supply. So now that this is done, this is how the token gets deployed. So once that is basically done, you can basically check the address of the token. So another way to ensure that you're able to follow along is Hardhat gives us a separate special feature called console.sol. So you could just import that as well. So you just have to do import hardhat slash console.sol, and that's it. Now you can basically do console log within your smart contract itself. So now that the token got deployed, you can basically check the address of the token as well. So the address of the token is basically, let's just call it token ad. So you can just typecast the contract into this, and let's just console log this, and let's also return this because this is what our return argument also says. So now that we have done this, we also need to use store the memory description and things, because that's important for showing the things in the UI, if you remember. So to do that, let me just show you what I'm talking about. So you can see here that each token has its own token symbol, token name, token description, and you also have the image. So if we want to do that, we need to record these. So let's create a struct actually to record all of this. So I'm just going to create a struct, and the struct's going to contain the name of the token. It's going to contain the description. It's going to contain the it's also going to contain the symbol. So let's just do string memory symbol, name symbol description, image URL. And let's just do this for now. And let's call this struct as a meme token struct. So we have defined the struct. So this is it. Okay, you're not supposed to put in these variables within the struct. So once you've defined the struct, now let's create a mapping that basically maps the token address that we just got to the struct that we just are recording. So let's create a mapping now. And the mapping is from the address to the meme token. And let's just call it address to meme token mapping. Okay. So now that we have created the address to meme token mapping, uh, what we could do now is essentially just create a new variable here, which is right here. Let's just go back here. We have meme token CT equals new token. This creates a new token. Now we got the meme token address as well. And now if you want to create the object in the form of this struct, what we can do is we just have to give it meme token, and let's just call this newly created token. And for this, we're going to use the new keyword, and we're going to do meme token off. And what does it require? Name, symbol, description, symbol, description, and token image URL. So the token image URL, okay, is image URL here. So this is basically it. So now you've created a variable here called newly created token, and this is identifier is not a contract. Okay, let's see. Okay, we don't put the new keyword. The new keyword is only for contracts. Sorry about that. So now that we have done this, the next thing is to basically put it in the mapping. So address to token mapping. And now we have the meme token address. And we're just going to map it to our newly created token. Now you're basically done the job of creating the meme token. You're actually deployed it. You have minted an initial supply, which is 20% off the max supply. And you've also captured the meme token address. So what we can do now is we can write a simple test in test.js in the test folder in order to test this out. So you can see here there's already a test basic written for lock.js, which is going to copy the similar outline, but we're going to do it for token factory. So I'm going to create token factory.js, and to start with, what we can do is we can directly go into our what are dependencies which we require. We require expect, which is the chai assertion libraries, etc. Then you require the Hardhat package. That's it. Now to start writing the test, you've just got to follow this format, describe and it. So let's just do this, and the tests are for token factory. So yep, now every test basically is written within this. So now let's should so the first test that we're going to write is going to be should create the meme token successfully. So let's check that. Okay, and what you've got to do next is okay, here's where we write our code for actually doing it. So let's first deploy our token factory, and to deploy that token factory contract, we're going to make use of Hardhat ethers. So hre.ethers basically has a function within it called deploy contract. And to deploy the contract, you just have to give it the name, what you've given here. So for us, it's token factory, and that's it. Once you have done that, we're going to create a transaction. And this transaction is going to be for calling create meme token. So let's just do token factory ct dot let's copy this create meme token, and let's pass our token details into this. So let's give it what are the order: name, symbol, description, and image. So let's go with Dogecoin, Doge. This is a Doge token, and you also need an image. For now, I'm just going to write image.png. Yep. So I'll just turn on word wrap on this as well. Yep. So now this is a transaction for creating the meme token itself. And now what you can do is one more thing that we did forget is for creating the meme token, we want to charge a fee as well. So let's also put in a constant for that. So let's have a meme coin, a meme token creation fee. And let's set the meme token creation fee to 0.001, 0.001 ether for now. This can always be changed. And what we're going to do is before this token gets deployed, we're going to do the check to ensure that the user has actually paid that much amount of tokens in msg.value. So to do that, you've just got to go into this and do msg.value greater than equal to the meme token creation fee. Otherwise, invalid token creation fee. This is going to revert otherwise. So msg.value. So oh yeah, we need to make this function payable. So you can make it public payable returns address. So this basically does this. Now we can go here, and if you want to pass value as well in this token factory, what you've got to do is after the last argument, you've got to put in the value field, and over here we're going to uh, use the Hardhat library again within ethers library again to parse ether to way, because you have to pass the value always in the way denomination. So now that this is done, this is the transaction to create the meme token itself. And what we can do now to check is we can basically just see if our console log gets printed, and that should basically verify that our token got deployed successfully. So now to run this test, what you can do is you can just do npx hardhat test followed by test slash token factory. So when you don't specify the network in which you want to test, it's going to test by default on the Hardhat default network, and that basically means it's going to create like a local blockchain and it's going to test it locally. So let's do that for now. Okay, so you can see that our test basically passed. Our token factory contract got deployed, and this console log that you're seeing is actually the meme token address. So that's what you're seeing it right here. Let's just meme coin successfully deployed to, and you can see this. So that's how you can basically create the meme token itself. Now coming to the next part of it. Once we have basically done this, the next step is to probably implement the struct itself. So like I said earlier, every token basically has like a funding value that it's raising. So let's add that. So the way this works is every token basically tries to raise a certain amount of ether. I mean, every meme token. And if it crosses that threshold, which it is supposed to raise, then the liquidity pool gets created on Uniswap with the supply that we just reserved here. So now to track the funding raised per this particular token, we're going to have this variable. And initially, this variable is going to be 0. So let's set it to 0 here, and this basically tracks the funding that's raised. Let's also record the addresses. So let's record the token address, and also let's record the creator address of this token. So you're gonna have two variables, and let's pass that in as well here. So we have the meme token address already here. So meme token address, and the creator address is just msg.sender. So we have captured that as well. So now for a meme token, you're able to have the name, symbol, description, the image, how much funding it's raised, token address, and creator address. And let's also define a constant that determines how much is the required funding. So for that, let's just call this meme coin funding goal. And let's set this meme coin funding goal to exactly 24 ether, and I'll tell you why. So the meme coin funding goal, if you look at pump.fun, you can basically see that the funding goal is 69k dollars the moment it reaches the bonding curve, which approximately comes around 85 sol, I believe. And similarly, we are going around the same number. So we have set 24 ether as the value for the funding goal. So coming back to our contract, we have the funding goal already set. We are recording the funding. Next function is to basically create the to actually buy this particular meme token. So let's create a function now that's called buy meme token. So what we're going to do in buy meme token is you're going to have two arguments. One is the meme token address itself, which you want to buy, and how much quantity you want to buy. Uh, let's call this purchase quantity. Yep. So this is the function. This function needs to be a public function because it can be called by anyone, and it's also payable because the user is going to pay an int. And let's just do returns uint for now. Okay, so now coming to the function itself for buy meme token implementation, what we have to do first is we have to check whether the funding goal is basically reached or not. If the funding goal has reached, then you don't want to let the user buy that. But before we go into funding goal, let's actually see whether the meme token is present itself or not in our platform. So you shouldn't be able to buy a meme token that's not in our platform. So let's create a function that basically checks that. So we're just going to do require, and we're going to use the address to token mapping. And here you're going to pass the meme token address. So now you've gotten the struct, and what you can do now is within the struct, if the token address is basically 0, which is the 0 address, then it means the token does not exist. So you've got to ensure that it's not equal to address of 0, and there you're going to write down that okay, we forgot dot token address. So within the struct, you're accessing the token address variable. You're checking that it's not equal to the 0 address, and you're saying the in case it's not there, token is not listed in the platform, so you cannot buy it. So this is the first condition. The next condition would be to actually ensure that the funding goal has not been met. By now, if you're past this, then it means that you're basically know that the token is in the platform. So what we're going to do is we're going to create a reference to that meme token itself. So let's just do that. So meme token storage, and let's call this listed token, which you're trying to access. And for this, we're going to again go into address to meme token mapping, and we're going to take the meme token address. So now that you have this, this is denoting our listed token. The next condition that we have got to check is ensuring that the funding goal is not met. So to do that, you've just got to do this require address to meme token mapping of the meme token address. And what we're going to do is we're going to look at the funding raised over here, this variable. So let's look at funding raised is less than or equal to the meme coin funding goal. So in case it's more than that, then it means that funding has already been raised. And if this has already been raised or the funding goal has been exceeded already, then it means the liquidity pool has already been created on Uniswap. So this is one condition that we have checked. Now the next step is to actually ensure that you have enough supply to that the user who's trying to buy a purchase quantity tokens, we have enough supply. So to find that, let's first find the current supply of our token. So to find the current supply of our token, the way you have to do it is you have to go into our ERC20 token. And if you go into our contract itself, you'll see that there is a function here called total supply, and that returns the total supply. So we have to access the token contract to do this. So for this, we're going to create a token contract reference, and we're going to just do token of meme token address. Now you have a reference to the token contract, and the next step is to actually get the total supply. So to get the total supply, you're going to do this actually gives us the current supply. So current supply just tells us at any given moment what's the total number of tokens that were minted. So UN current supply is equal to token CT dot total supply. So we've got the current supply. So now you also know the total, the maximum supply. So the available supply is actually, if you look at it, it's going to be always equal to the max supply minus the initial supply. The available supply is, let's just think about it again. So the current supply is going to be token ct dot total supply. Once we have got that, the maximum supply of the token is max supply, which is 1 million tokens. So if you see how much is actually available for sale, it's 800,000 because 1 million minus the initial supply, which is reserved. So you have 800,000. So available supply is actually equal to max supply minus the current supply, because the current supply is already been minted. Yep. Uh, one more thing that you do want to ensure is let's just check once to ensure. Okay, so you have available supply of 1 million was the supply minus the current supply right now is 200,000, because it's already minted 200,000. So it means that there's 800,000 tokens available in supply. So this is correct. So now that we have established that, the next step would be to actually scale this available supply. So let's just call this available supply scaled, and let's do available supply by let's divide this by the decimals, because this is we are going to go into our next step of the function. So we're going to scale this for our thing, and the token quantity that the user is also planning to buy, we're also going to scale that. So purchase quantity scaled is going to be equal to the purchase quantity that the user wants to buy uh, multiplied by the decimals. So now you have the available supply and the purchase quantity which the user is planning to buy, and available supply scaled and the token quantity scaled. So what you've just got to check is you're just going to check that require purchase, the amount of quantity the user is planning to buy should always be less than equal to the available supply. So otherwise we're just gonna put an error that not enough supply. So now that this condition is sorted out, the next step is to actually calculate the cost for purchasing the token quantity tokens, and we're going to do that now. So let me just write a comment, calculate the cost for purchasing this many tokens, purchase quantity scaled tokens. So now coming to our cost, let me just give you a quick overview, because this is where the part about the bonding curve comes in. So if you have a constant bonding curve, then it basically means that the cost of one token is always fixed. So it's equal to a certain value of ether. But we don't want to have that sort of a bonding curve. So we're going to use the exponential bonding curve. So different bonding curve options which are present. I'll be giving you a quick walkthrough of that. So like this says, a bonding curve is just like a mathematical function that defines the relationship between the price of the token and supply. And the way pump.fun actually works, it basically uses the exponential bonding curve, which means that the users who are buying early are going to be able to buy in for cheap, and the people who come in late to buy are going to pay a lot more, and the price of the token goes up exponentially. So that's about bonding curves. You have different kinds of bonding curves. You have a linear bonding curve, which is just a linear increase in the price when a particular token is purchased. Then you have an exponential bonding curve. So this basically is an exponential increase in the price as the supply keeps increasing. The cost of buying the token also is going to increase. A logarithmic bonding curve, and you can see here that these are some common bonding curves. So over here, if the supply keeps increasing, the price also increases, and you have to choose the right curve. There are different ways to choose it, depending on how you want your price function and your tokenomics model set for your particular meme token. You can basically choose the right curve. Since pump.fun has a exponential uh, curve, we're going to go with an exponential curve in ours as well. So you can see here that the exponential bonding curve has the following function. The price function looks something like this. So if you were to plot it on a graph, right, this is how it would look. And if you want to find out, okay, when you are at zero and you want to buy the entire supply, the cost is actually going to be equal to the area under this curve. And you can find out the area under the curve by using a concept called integrals. So we're just going to go rough, not too much into the math. But once the price function is basically defined and set over here, the next step is to actually calculate the integral between the current supply and the supply after we have bought X number of tokens. Once you have done that, you come to an equation that you see over here. You have two constants, which is P naught and K, and P naught and K basically determine uh, the following, which you can see right here: the initial price per token in way, and K is the growth parameter, which indicates how quickly or how steeply the price increases. So these two parameters you can just go by trial error. You can come up with certain values, and for our equation, what we are doing is we are going to set that, okay, if the user has 0 tokens and he's buying the entire supply, which is 800,000 because 200,000 is reserved, then it's going to cost the funding required, which we already saw, which is basically 24 ether. So when you try to simplify that, you arrive at certain values. And let me just go back to our smart contract. So for going into this, I'm just going to paste an implementation that I've already written here for our exponential bonding curve. So this is where we have our function. Okay, so let's just go here. Let's paste it over here. So you can basically see here that this is a function to calculate the cost in way. And for given a current supply and the tokens you want to buy, it calculates the exponent and it scales it. So if you look at it, this is exactly the equation that we just see here. So e to the power k c plus k, k into c plus k. So the current supply plus the tokens to buy, and the next term is e to the power kc. So exponent 2 is kc, and we are multiplying it by 10 power 18 in order to actually scale it to avoid precision loss. So you're going to calculate the exponent of this particular value, which is e to the power exponent of 1 and e to the power exponent of 2, and we're going to store it in these two unit value. So if you look at the cost formula, this is the formula that we saw right here, which is p naught by k into this. So this is the implementation right here, and you're again keeping this constant value in order to ensure the precision scaling. So what we're going to do next is we're actually just going to have to implement the exponentiation function. Now, a easy way to implement the exponentiation function, because it's pretty expensive in Solidity, is to use the Taylor series. So Taylor series basically shows you the exponent function. So within this, you can see that e power x can be approximated to this value. You have 1 plus x squared by 2 factorial, etc. So we're just going to do this for up to like 20 terms. So I have the function written over here for calculating this exponent. So let me just open this up and paste that right here. So you can basically see that the exponent function starts with a given value and it does the iterations like we saw over here to calculate it based on this particular method. So to do this again, now we have certain constants which we are left with, which is P naught and K. So P naught is the initial price and K is the other scaling factor which we saw. So if I were to go back to our presentation, you can see it right here, P naught and K. So upon trying different values, we arrived at a value over here, which is the which I'm going to put, and you can basically see it. Right. So this basically shows us the initial price. This is like if you're just buying one token, it's going to cost you this much initially, and the growth rate, you can basically see it over here as well. So now that we have done that, you basically have the cost function, everything ready as well. What you can do is you can basically call the calculate cost function in order to calculate the cost that's going to be required for purchasing this. Now, one thing that we have got to do is we have got to scale our current supply. because the current supply is going to show as the total supply, and we don't want to factor in the 200,000 tokens that are already minted initially. So what we're going to do is we're going to subtract the current supply. We're going to just write current supply scaled, and we're going to take the current supply that we already have, and we're going to remove the 200,000 from it, which is the init supply. Once you've removed that, the next step is to basically again divide it by the decimals, because we want to scale it over here before it goes to the cost function. Now that we have done that, what you can do next is basically to call the calculate cost function. So now we're going to have required ETH, and we're going to call the calculate cost, and the parameters for this calculate cost function is going to be the current supply scaled. So I'm going to pass the current supply scaled and the token quantity that the user is also planning to buy. So since we have divided by decimal, you're going to pass this purchase quantity. You're not going to pass the scaled purchase quantity. So once you've done that, you'll basically be able to get the required ETH in terms of cost. And for now, what we'll do is let's just return this value. And what we'll do is let's also console log this required ETH so that you can see how this exactly works. Coming back to our function now here, we're going to write another test, and we're going to write this for letting the user actually purchase purchase the meme token. We haven't implemented the purchase part yet, but we're just going to call this to see what it returns for the required ETH. So now we're going to let's also get the meme token address for our particular meme token that we're creating. So what we can do is let's also just create a address array, which basically keeps track of all the meme token addresses. And let's just call this meme token addresses. And this is going to contain all the meme token addresses that we're doing. And once you've gotten this over here, after it's created, we want to push to that. So let's just do that again. Meme token addresses dot push, and let's push in this meme token address. Once you've pushed in that meme token address to this meme token addresses array, okay, member push not found. So let's try to see what the error exactly is. Um, the address array is a public array, yes, meme token addresses, and let's just go back to our create meme token function. Um, 1 second. Let's just see. All right. So looks like the error was just to the variable. So the variables actually meme token addresses. So we just got to change that to meme token addresses, and you're going to push the meme token address to it. So now you've basically got the meme token address within that. So now that you've created your first meme token, you can access the meme token address by just accessing the variable itself. So what we're going to do now is we're just going to take the meme token address by accessing the first variable. So let's just do this, and let's access the token factory CT. And we have to access which variable? Token addresses. Since it's a public variable, you have a getter function assigned to it. And now you could just do of 0. That's going to give you that. Now you've gotten that. Now we have to create another transaction to simulate the buy. We're gonna do that now. Token factory dot buy and see what the function name is again. Okay, it is buy meme token. So let's put buy meme token here, and we need to pass the meme token address, which we've already gotten. Meme token address and the quantity. So now for our simulation purpose, right? What's the remaining supply totally which is present available for users to buy? It's essentially 800,000 because initially the maximal supply is set to 1 million and 200,000 is minted, but it's pre-reserved in case everything gets sold out, which is the meme coin funding goal is reached. So to attain this meme coin funding goal of 24 ether, you the maximum value is 800,000. So let's basically simulate that again. So we have the buy meme token, and we're going to buy 800,000 tokens. So within this, the value that's going to cost here for buying this many tokens is going to be uh, 24 ether by itself. But anyways, since we're just returning the cost, right, in way, we can we can ignore the value right now because anyways, we are not checking msg.value at all in this. So let's just ignore this for now, and let's call this and see what happens. So when you call this, it's going to emit our console log, which is required ETH. Let's just put one more required ETH for purchase. This, you have the required ETH right here. Now let's run the test. Okay, we have an error. So should let the user not enough supply. Okay, which means that there was an issue somewhere where we created the max supply. Okay, the max supply should have been 1 million tokens. So 1, 2, 3, 4, 5, 6. So now that's set. Let's just try it again. Okay, it says not enough supply. Let's look at why that is. Within our buy meme token, available supply. Okay, let's just console log some things. Purchase quantity scaled. Okay, our purchase quantity scaled is okay. We actually have to, I think there's an issue right here. Let's just check it again. Uh, Within buy meme token, we want to see the purchase, check if there's enough supply, and you actually don't want to compare the purchase quantity scaled here. You want to compare the purchase quantity because that's the unscaled value, and the available supply scaled is divided by the decimal. So we're just going to take this here and ensure this is the case. Now that we have done this, let's try running this now. Purchase quantity. Okay, so now you can basically see the required ETH for the purchase is 24, this much. So if you go to a ether to way converter, ether to way converter, then you'll basically be able to put this in way, and you'll see that it costs exactly 24 ether if you want to buy the entire supply in one go. So now that we have sorted the cost functions out of the way, the next step is to basically check if the user actually has enough ETH for making this purchase now. So this means that you've got to go into msg.value, and you're going to check if he has paid more than or equal to the required ETH. If he pays more, then it just goes into the contract. So in case he hasn't, then you're going to throw an error incorrect value of ETH sent. So that's the catch over there. And once this is done, which means that it's passed everything, the user has paid it. Now the user should get the tokens. So for that, before that, we're going to increase the funding raised because the user has contributed the funds now. And what we're going to do is we're going to increase the funding for this listed token. So you're going to do listed token dot funding raised plus equal to the amount which the user has paid, which is msg.value. So now that we have done that, we have incremented the funding raised. The next step is to also check if the user, okay, the value ETH, we have checked that. And we also have to actually mint the number of tokens for the user itself, because when he's actually buying these tokens, it actually means that we're minting the token itself. So to mint the token itself, you're going to have to access the token contract. So like you can see here, have we created a reference for the contract? Yep, here we go. This is the token contract, and within the token contract, we are going to require a function that's called mint. So let's create that. So we're going to create a function called mint that's going to say quantity and receiver of these tokens. So now that you've sorted that, you don't want this function to be called by anybody. So you're going to set this as a internal function. Actually, it's external because you can only let the other contract call it. And one more thing that we're going to do is we're going to have an admin address or the controller address. And this admin address is going to be set in the constructor to the token factory contract itself, because token factory deploys the token.sol. So the admin is set to token factory itself. So the next step is basically to leverage this in order to just call the mint function now. So we're going to check to ensure that the caller of the mint function is indeed the admin. Okay, otherwise we're going to throw caller not admin. Uh, and we're also just going to return a event. Let's just simply return, and over here we're going to call the internal function within ERC20 implementation. So you can see here, if you want to mint, you have this function, which is the function, an internal function to mint it. So we're going to call underscore mint, and we're going to mint these tokens to the receiver. So let's copy this, and let's mint the quantity as requested to the receiver, and let's just return one. Now that we have the mint function sorted out, you can basically go back to our thing. Okay, funding raised has been done. Now we have got to actually call the mint function itself. So let's call the mint function next. So that's token ct dot mint, and we're going to actually mint how many tokens for this particular user, the purchase quantity scaled. So we need to copy this because we're going to mint that many scaled quantity, and we're going to mint it to the msg.sender of this, which is basically the user calling this function. So once the tokens are minted, you've basically implemented a basic version of the buy function, because now we could again verify that the user balance is correct or not by just console logging. Let's do this. So let's use token ct, and let's use the balance of function within that in order to find the balance of the user. So You're gonna do msg.sender user token balance is, and we're gonna do this. That's it. Um, Semicolon. Now one more thing, since we have kept a check, you have also got to modify this in the buy meme token. So you're going to pass an additional field and you're going to say value, and here's where you again put in the value for buying these tokens. So like we did the calculation, it's going to cost us 24, so this should be it for us. So this is going to parse the ether to 24. Looks like we have some error. Okay, this should be a comma. Yep. Now we should be able to try this out. Let's call the test function again. Okay, so you can see the user token balance has increased to 800,000. This is showing the scaled value 800,000 times 10 power 18, and it has let the user purchase the tokens. So that's a basic implementation of the buy function. Now coming to the next step, right? What is exactly the next step is if the funding raised, right, after the user has bought it, everything, uh, if the funding raised has already crossed the required funding. So if you look at the funding required, which is basically 24 ETH, let's go back here, meme coin funding goal. What we're going to do is if the list token dot funding raise is greater than equal to the meme coin funding goal, what you really want to do next is you basically want to create the liquidity pool on Uniswap. And while creating the liquidity pool on Uniswap, we're going to make use of Uniswap libraries to do that. So let's actually just try to understand how we can create the liquidity pool. So first step is to create the liquidity pool on Uniswap. Once you have created the liquidity pool on Uniswap for the tokens, next step is to actually provide the liquidity to the pool. And once you've provided liquidity to the pool, the next step is to actually burn the LP token that represents the pool. Liquidity position. So these are the three functions that we have got to actually implement. So what we're going to do now is let's start with actually creating a function to create a liquidity pool. Underscore create liquidity pool. And you want to pass the meme token address itself to this. And that's basically it. And this function is going to be an internal function that returns the address of the pool. So to actually create this, let's go into Uniswap docs and try to understand how you can create a liquidity pool. So for this, we're going to actually use Uniswap v2 because it's the easiest for us to just create a liquidity pool. And like you can see, there are two contracts repos, Uniswap v2 core and periphery. If you go into Uniswap v2 core, let's just go into the smart contract integration, technical reference, and you have the API, you have the smart contracts. Let's go into the factory. So you can see the factory has the following functions, and we need the state changing, we need this function called create pair. So let's first get all of the smart contracts set up for us. So to actually get all the smart contracts set up, you're going to have to install these dependencies. So let's do that for us now. So we're just going to npmi. Once you've done this, you will notice the contract will come up under the node modules. You can see right here, we have Uniswap v2 core. Now we also need the v2 periphery. So let's also just install that. Okay, now that we have basically installed the V2 core and periphery contracts, within the V2 factory, you basically have this particular function, which is basically to create the pair. So let's basically import this interface if you want to use it. So let's basically just copy this line, go back here to the imports, and let's import V2 core interfaces. Yep, we've imported that successfully. So now to create the liquidity pool, we are going to need the addresses of the factory contract itself. So you just go into V2 deployment addresses. And what we're going to do to test this out is we're going to run this on the ETH mainnet fork in Hardhat. So we'll also see how you can set up your ETH mainnet fork on Hardhat. And let's just copy the mainnet addresses. So let's set that right here. Let's address constant Uniswap v2 factory address, and let's just copy this right here. Okay, let me just copy that again. Yep, that's done. And the next step is to create a variable for the router address, and this is the address, and that's basically it. So we have gotten this. We have created the factory and the router variable. So the next step is to actually just come in and create the particular liquidity right here. So what we're going to do is we're going to import the interface. We already have that set up. So you just have to do I uniswap v2 factory, and let's just name this the factory. And we're going to create the interface with pointing to the address, which is uniswap v2 factory address. We also require the router because we basically require the router address as well, because the router address gives us the wth pool. So now after this, to create this, you're going to call the factory dot create pair method that we just saw here. So you have the factory, and within the factory you have the create pair. So this is what we need. So let's just go into this, and address of pair is going to be equal to factory dot create pair. Okay, and if you actually look at what are the arguments required for creating the pair, address of token A and address of token B. So the pool is actually between the meme token and wrapped ether, and this basically we'll be getting now. So let's put the meme token address, and the router basically gives us the wrapped ether's address. So if you go into the v2 router contract, you'll be able to see. So v2 core periphery, v2 router 01, and yep, you basically have the wrapped ether's address within this. So that's on the yep. Now that we have the pair created, uh, let's just ensure, yep, we can basically return the pair address. Seems to be an issue over here. v2 router 01. Okay, we have not imported the v2 router contract, so let's import that. So router 01, if you go into that, let's see if they have given us an import that we can just copy. Okay, there it is. So this is the interface. So you've just got to go paste this. Now we have imported the router interface as well for our particular thing. There seems to be an error somewhere. Okay, address. Yep. Address of the pair. Now the liquidity pool is created over here. So what we are gonna do is let's go back to our if. Okay, so address of the pool is equal to underscore create liquidity pool, and we're gonna pass the meme token address. Here the address is this, the address that the user wants to buy, and you're gonna paste the meme token address inside, and you're also going. That's basically it. Yep. uh, that creates the pool by itself. That's it. Next step is to actually provide liquidity to the pool. So let's create a function called provide liquidity. And this function is going to take the token address. It's also going to take the token amount which you're creating, which how much you're adding into the pool, and also how much is the ETH amount that you're adding into the pool. So these are the things which you're putting. So let's make this an internal function that returns the liquidity provided. So now the next thing is to actually interact with our token contract, because the way it would work is the router contract would need to pull the token from your token factory.sol, because the token that we have reserved here is the 20% is present within this smart contract. And when we are calling this function, the router is actually going to try to call the transfer from of the ERC20 implementation of the contract. So you have to create so you basically have to approve the token address. So let's do that now. So let's just create a meme token contract interface again. Now we're going to pass the meme token address. 1 second. All right, so next we're going to do is we're going to paste the meme token address right here. So once you have done that, we've created the interface. Now you can basically call the approve function. So what we have to do is we have to call the approve function within this. So if you go into the ERC20, you'll see that there is an approve. So we're going to call meme token ct.approve, and we have to approve the router address because the router is the one which is going to call it. So to approve the router address, let's put in the Uniswap v2 router address, and we're going to approve token amount. So the token amount is basically the amount of liquidity you're providing, and this token amount is obviously equal to this much, the 20% of the max supply. So now after that, after you basically approve the tokens, now comes to actually provide the liquidity. So if you go into the router 01, you'll see that there's a function. There are multiple functions over here. So the one we need is basically called add liquidity ETH. So let's go on top and okay, add liquidity ETH. So adds liquidity to an ERC20 W ETH pool with ETH. So this is what we're trying to do. We want to add liquidity to this pool between our meme token and wrapped Ether, and we're going to do it with ETH. So that's basically the fields you can see right here. So I'm going to go ahead and basically create an interface of the router is and you're going to paste the Uniswap v2 router address into this. Once you have done that, that's basically it. Now the next step is to actually call the liquidity ETH function, add liquidity ETH function, which we see right here. And let's do that now. So if you want to try to understand what exactly are the parameters here, you can read through this, and it says the token is basically the meme token address. Then you have amount token desired. to add as liquidity. So this is not required because this is like you're adding it to a freshly created pool. So the amount of token to add where is going to be entire amount. Then the next thing is basically going to be the ETH amount token min, which basically determines how much is the amount of tokens after the transactions in the pool. So that's again going to be the same because there's no liquidity in the pool yet. Then you have the amount ETH min, which is also going to be equal to the same because the total amount of tokens and ETH we're putting is going to go into the pool, irrespective of that. And the recipient of the liquidity tokens is going to be this particular contract, which is our token factory. So our token factory should get the liquidity tokens, which is the Uniswap LP tokens. And deadline is you can ignore the deadline because we can just add block.timestamp, and that's basically it. So rest of the three are the return arguments, the amount token, ETH, liquidity, and things. So what we'll do is let's call this now. I'm just gonna call this function, and after this I'm just gonna return the liquidity. Okay, so I think there's a spelling mistake. Let's just copy this, paste here. Yep, now the liquidity has been provided. So let's call this function now. We want to call provide liquidity, and you want to provide it for the meme token address is the address, and token amount that you want to provide the liquidity is going to be initial supply because if you're aware, 20% of the tokens go into the pool, and next is the ETH amount. So to get the ETH amount, right, what we're going to do is we're going to extract the ETH amount instead of just putting blindly 24 ethers. What we're going to do, we're going to extract how much funding was raised so that it always accounts for that. So ETH amount is equal to what's our pointer to the variable? Yeah, listed token dot funding raised. So now you have the ETH amount as well. So you could just add the ETH amount right into this, and that's basically it. So let's also just add some console logs so that we can see console log pool created, address is, and let's just print this. Okay, now liquidity added. So liquidity added to the pool. Let's add a console log again. And let's put in liquidity, which is this variable right here. Yep. Now the next step is to actually burn the LP tokens. So now to burn the LP token, let's create a function here. And what we're going to do is we're going to call the burn LP tokens with the pool address and the liquidity as the arguments. This is how you can basically identify a liquidity position, and each LP position has the pool address and how much liquidity you actually want to burn. So now that you have done this, now we have to actually go into the Uniswap V2 pair contract because let's go back here. Within the pair ERC20 contract, here you will have this is the pair which determines the pool tokens, the Uniswap V2 pool tokens, and here you will see that there'll be a burn, and okay, you have the name symbol. Okay, here it is. Emitted each time there is a burn. Okay, so let's see. Okay, they have not given us the burn implementation here, but it's basically ERC20, so it should be straightforward. So what we're going to do is we're going to first import the interface of that. So to import the interface of the V2 pair contract, let's just see our Node modules, you have it in v2 core. Inside v2 core and contracts, you have v2 pair.sol. That's what we need. So I'm just gonna put that v2 pair.sol. Now we're going to go in and create the interface again. Okay. And now to actually burn it, what you're going to do is you can just call the transfer function and transfer to 0 address. And that's essentially what burn is. So what we're going to do now is we're going to uh, burn the tokens by calling the transfer function. And next step is to basically just console log that we burned it. So LP token is burned. And you can basically just put this so that you can see how many liquidity tokens were burned. And yeah, this is going to be an internal. We could just write returns uint and we could just return one. So now the next step is to actually go back here, burn the LP token, burn LP tokens, and the arguments are again the pool address, which is and the liquidity. So that's basically on our buy contract implementation. So let's just go through it and see if we've missed anything. So we have incremented the funding raised after the user has bought it. Yep, by msg.value. That is correct. The next step would be to check if it's done, if we have raised it. We've already minted the tokens over here to the user. That's also done. So the user gets his tokens he just purchased, and the user's balance is also done, and that's it. So that's the implementation of the buy function. And let's go back to our test and let's test it out. So let's just continue this because, okay, so when a user is actually trying to buy 800 tokens, it basically crosses the 24 ether limit. So that's essentially going to let us be able to simulate this, because it's going to come into this if condition, and when it comes into that, we're going to get the pool address, etc. But one thing before we go forward is, because you can't we have put in the addresses which are corresponding to mainnet, you would need to actually be able to deploy this on mainnet and test. But luckily Hardhat provides you with a way to test without essentially deploying on mainnet itself. You can create a fork. So to do that, let's first just install the .env package. Once you have installed that, create a .env file. And what you basically need is you need an Ethereum mainnet RPC URL. And to get the ETH mainnet RPC URL, you can just head to admin.moralis.io. And once you're in the platform, you basically can head to the, okay, let me just log in again. Okay, you can basically head to the node section, click on create a node, select Ethereum, select mainnet, and create it. Once you have created the node on ETH mainnet, you will get the RPC URLs right here. Just copy the URL. I'm just going to copy one. Now come back to our env file, paste the RPC. Now that we have pasted the RPC, the next step is to actually go into hardhat.config. This is where we're going to make the settings for the forking. So within this, what we're going to do is, the next step is to add a parameter called networks. And here you want to put in hardhat network, and the URL of this network is going to be process.env.mainnet RPC Ethereum mainnet RPC URL. So that's on this front, and let's also just put in the chain ID. Yep. So now that we have created this, you will basically be able to call the test function and actually test it out, because it's going to interact with a fork of the mainnet, which means that all the contracts available on the mainnet is available in our local network, which lets us test it. So let's uh, call the test method now. Moment of truth. Okay, so Hardhat doesn't have a URL. Okay, oh yeah, we forgot to import .env.config. Okay, now that we have done that, you should be able to call the test. Okay, we are still getting some issue over here. So URL invalid value undefined. Okay, the URL is getting undefined for some reason. We have installed the .env. Let's just see if we have kept it in the right place. Hardhat ethereum mainnet rpc URL package json. Yep, it does have .env ethereum mainnet rpc. Let's just put this first. .env.config. Okay, let's try putting network, and let's put the tab. Okay, I understood why. We basically missed the to add forking to it because we have not put in the bracket here. So this was a bracket error. So now that we have done this, you should be able to put the URL here, and this should work now. So let's just clear this. Okay, expected value of type string. Um, let's see again what's the issue with this. So you have the networks. Within the networks, you have Hardhat. Within Hardhat, you have forking, and within the URL, you have the RPC URL. The .env holds the URL itself. Let's try chain id.url. Okay, not sure why that's happening. Let's try putting in the URL directly over here because that should technically work then. See, we have the URL right here. Okay, expected a value of type string. Chain ID, it works. Okay, it looks like everything is correct. Let me just paste configuration that I have right here for me. Okay, mainnet rpc URL. Let's also change this. Okay, great. It's working now. So you can basically see right now that it's running the test. It's taking a bit of time, but let's go back here and let's see. Okay, so the meme coin was successfully deployed. This is just the console log that's printing because we've put console logs there. And now the third test, which is should let the user purchase the meme coins, also complete. So the required ETH for this, the user's token balance after the purchase was 800K, and the next thing was the pool address, which got created. The liquidity got added to the pool, and the LP tokens got burned. So that's essentially what you can see right here. In terms of our function, we have basically executed this part of it. and now everything basically is ready from our contract perspective. So we have the exponential bonding curve function, we have the buy function, we have the create meme token function, we have the meme token creation fee, and the moment it exceeds, you'll basically also realize that okay, the funding raised will be incremented, and if it tries to come into the loop again, it won't be able to because the funding has already been raised. It would have already exceeded. So that's how you can create the token factory contract for testing your pump.fun clone. So like you can basically see, you can customize this even further. You could give it your own bonding curves. You could set different values of funding required to actually put it into a liquidity pool. And you could also have like different mechanisms as well for your LP token management, etc. So that's on the token creation part of it. So coming back to our agenda, let's just okay, we have covered how you can build the smart contract for pump.fun. So the next step is to just look at the front end. So let me just open the front end repository as well. Okay, so here I have the front end repo, and let's basically go through step by step. So this basically is the home component. So in this home component, let's see what's actually happening. So you've got to put in your Moralis RPC URL in the env, follow the env example, and create the env file. Once you have done that, the first step is to actually fetch the active meme tokens. So to fetch the active meme tokens, we're calling the get all meme tokens method in the smart contract. Once we have got the meme tokens through calling this method, so I think we've just missed this. So you could essentially just add a view function as well over here called get all meme tokens. And this is going to be a public, and this is going to be a view, and that's essentially going to return, what is it returning? It's returning an array of meme tokens. So let's put in meme token array, and we've also got to put memory keyword because yep, and you can implement the get all meme tokens implementation right here. So one way to do it is just to iterate through our array of meme token addresses, since we already have it, and you can basically just create this and you'll be able to return it. So that's on the meme tokens. So the meme tokens which it is returning are present right here. You can see it's returning all these fields: name, symbol, description, the token image, the funding raised, etc. And we are rendering it in the card. And you have the search. Apart from that, it shows you some details about the funding raised, the ticker, the description, etc. And that's majorly what the landing page shows you. So now we could go into start a new coin, and let's go into the start token create component. So over here you can see we're capturing these fields as the user input: the name, ticker, the description, the image URL, etc. is the user input. And then you have the handle create function. The handle create function is for actually creating the meme token itself, which is going to make an Ethereum transaction. And like we saw, it's going to call the create meme token method in our smart contract. So this method is the one it's going to call. And to call that, it's passing all these parameters. The value is also being passed for the meme token creation fee. And that's basically it. Once you get that, you get the transaction hash of it. So for our simulation, let's try creating a token. So let's just copy a token from pump.fun. So let's take SpongeBob. I'm going to copy the image address. Just give this a SpongeBob token. Let's put the symbol as sponge. This is a SpongeBob token, and the image URL is this, which we have just copied the image address. Now we're going to click create meme token. It's going to charge 0.001. Now you're going to confirm in MetaMask. And once you've basically confirmed in MetaMask, we're going to wait for a while for the transaction to get confirmed. Okay, let's see. Let's track it on the block explorer. Okay, now you can see the transaction successful. We got the hash. Now, if you go back to our main page, you can see right here, this was the token that we just created, the SpongeBob token. So this token, we can again inspect this even further because this contract is in Sepolia, right? You would be able to just open this up and you can see that we interacted with this contract, which is our token factory. And the token factory, you can see here, it's holding all the 20%, which is 200,000 tokens. And that's essentially how you can see our given contract address. Going deeper into our transaction, this was the token contract which we are again which got deployed, and again it reflects here. So this, if you go here, you can basically see the token contract is this. You'll be able to see all the transfers, etc. for it. So coming back here, this was a token that we just created. We have covered the token create component because we are calling the create meme token function, and the rest of the things are just some placeholder values that show you, okay, about the mechanics of it. The maximum supply is 1 million tokens and 200K is initially minted, and that is basically going on to Uniswap liquidity pool if the funding target is met, like we saw. So that's how it works. So now the next step is, let's go into a token view. So I'm just going to open this token up. It shows you the creator address, the token address, how much funding it's raised. And now you can see two things: bonding curve progress. The bonding curve progress indicates how close are we to reaching the liquidity pool. So if it hits 24 ETH, that's when the liquidity pool is going to be created on Uniswap, and it's going to create the pair over there. So right now we are not yet anywhere progress in the curve because we have not yet attained anything in the 24th. Now, if you look at remaining tokens available for sale, since we just created 800K tokens are there, and let's try buying some tokens. So let's try buying like around 50,000 tokens. I'm not sure if I have enough Sepolia Ether for this, but let's see. Okay, it's 1.5 ETH. I do have some Sepolia tokens. Let's do this. Let's hit confirm. Okay, now we're going to wait for this transaction to get confirmed. I'm just going to keep it open on the block explorer so we can see. Okay, the transaction hash been included. Okay, now it says the transaction successful. So now if you come back to this screen, you'll be able to see the bonding curve progress has gotten 1.58. And you can also see another cool thing here. Who are exactly the owners? Like you saw in the pump.fun, here also you can see who are all the owners of this particular meme token and how much relative to the percentage of the total supply they have. So since 200K versus the number of tokens we got, right? 50K tokens is very small. You basically can see the total supply, and you can also see the transfers. So you can see from this was the mint transaction, and if I were to transfer this token from my wallet address to another, that will also again show up. So now we have the token address. Let's import this token into MetaMask. Import token contract. Let's see what it says here. Sponge. Yep, Sponge. I have all the Sponge tokens. I have 50,000 Sponge tokens. Now I'm going to send this to my other account. Okay, I think I have to create another account. Create. That's it. Go back here. Let's send the Sponge tokens from here to the account 2. Let's send like 1,000, 10,000. Okay. And confirm. Once this transaction is done, you will basically be able to see how the table basically changes. So the table basically tracks all the ERC20 owners and the transfers. And you can basically see this was the transfer that we just did. And the transaction hash is also present. So you can see all the transfers along with it. So to get the ERC20 owners and the transfers, if you're building this up from scratch, it's going to be a very intensive process. So you can check out Moralis for getting the ERC20 owners with the help of the ERC20 owners API. So just go into Web3 Data API, go into the token API section, and here you have get token transfers. You can get the token transfers by the contract address. So here I'm just going to paste our contract address, which for our example is this one. Paste this, set the chain to Sepolia, remove the API key from this, and let's test. You'll be able to see here, this returns all the transfers of our SpongeBob token. So this is how you can integrate the ERC20 token transfers API for it. And now for getting the owners, you've got to go to get token owners, get the token owners, and here you can paste the token contract again, and you'll be able to get the ERC20 owners as well for this. Okay, you have changed to Sepolia, test. Yep. So here it shows you all the ERC20 token holders as well relative to the total supply. So this basically shows you how you can use Moralis API to do that. And coming to the integration part of it, in the token detail page, this is where we are seeing all the details of the token. Here we are making an API call. Let me just wrap this so that you can see it clearly. Yep, so we are calling the API in order to fetch the ERC20 token address, and you're passing the X API key. You can get the X API key by going into the Moralis platform and just go into the API keys section and copy your key. Once you have copied that, put it into your env as per, okay, this is our Hardhat. Put it into our env as per the env.example file, and you should be able to go good to go. So now if you go back to the token detail page, you'll see this is the APIs we're calling to get the transfers and the owners. To fetch the total supply and create the progress bars, this is where we are getting the funding raised by calling the contract and the total supply as well. To get the function, to get the cost of the purchasing tokens, here you're actually, here if you see what's actually happening when you looked at the purchase was okay, so if you looked at the purchase, that's when it's actually going to first call the cost function to determine how much it's going to cost. So for 100 token, it's showing 0.0 because it's a very small number. But if you try for a bigger number, it's going to show you how much it's going to cost you to buy that token. And now if you go, so you can see, if you remember, we bought 50,000 tokens, and as you keep buying, as the token supply keeps increasing, the prices increase as well. So that's essentially how you can buy the tokens. And for showing the price of the token before buying, we're calling the function calculate cost. And once we have calculated the cost, we are setting that into a state variable, and this is where the purchase happens. We're calling the buy meme token, which is the function in our contract to actually purchase the meme token. So now when buy meme token is called, we are just waiting for the transaction to complete, and that's basically it. So that's how you can get started to build your own pump.fun clone with the help of Moralis, Solidity, and Hardhat. I hope you enjoyed this tutorial, and if you did, give us a like and subscribe to our channel so that you could basically see more such tutorials. Thank you.